Okay, let's see. I'm going to share with you material for us for Friday. This will be great if you could look at it before Friday, and then we'll refer to it on Friday. So the focus for this week is on the visual representation of data. In some ways, there's not too much to it, so I am going to throw in a few other topics. Here we go. My goal is that after this week, you understand why data is represented visually, mostly through watching this presentation. That also we go deeper into logic models because they are really important to develop research questions that then you test with a single case research design. And then mostly together on Friday, we are going to evaluate and start to see how to evaluate single case research design articles, for example, like Golnoza's article that we've been working with. And then also on Friday, I would like everyone in a group, working in your group or working on your own, to begin an online search for existing research on your topic. So that's where we're going. Okay, chapter 7. There's a handout in the Google folder that has a few details, and you're going to see me coming back to that. If you want to pause my video right now and go grab that handout, you sure could. So just to review, reasons to graph data. For example, in a teaching or clinical context, it provides a teacher with immediate feedback about student performance, allows teachers to examine trends in student behavior, and can be used to provide students with feedback about their behavior or their academic or their functional performance. So I could graph data and show it to the kids if it was developmentally appropriate. Now, from a perspective of a researcher, there are two other reasons to graph data. It provides us with a visual representation of the effectiveness of an intervention, and it provides a method for others to judge the effectiveness of intervention. So the last one would be the idea, again, of critiquing an article. Okay, so the chapter has a lot of different graphs, but to really focus on what's relevant, it's really line graphs. Line graphs are really common, and they are used to represent the presence or absence of a causal relation or relationship between the independent and dependent variable. And basically, you are graphing data or showing information over time as time goes on. And we've already talked about that. So there are technically different components of line graphs. Because I know that the translation issue is daunting for a few people, I'll just go ahead and read through these, but they're basically information that you already know, but just to label them. The abscissa is the horizontal line, the x-axis, and it's identifying a time variable. For example, the number of sessions, days, or dates. The ordinate is the vertical line or the y-axis, and that is typically the dependent variable. For example, the number of correct responses per minute. The origin is the intersection of those two. There are tick marks, which are points along either the abscissa or the ordinate, and the values could be percentages. If that was on the ordinate, it would also be sessions, the numbering 1, 2, 3 on the abscissa. So then when you label things, the axis labels are basically corresponding to the tick marks. Those are numeric values. You know, I basically said sessions 1, 2, 3. The conditions are, the condition is basically sessions that are within procedurally similar contexts, like a baseline and an intervention. Those are two different conditions. And within baseline, it's procedurally similar. Within intervention, it's procedurally similar. Phases, you could, I don't see it too often, but you could have within condition variations. Actually, I think the book has one. So we could see that within the intervention condition, they're making procedural modifications. And then you need your condition labels, which means you're basically labeling the graph. And then you have a figure number and a figure caption. It's all very tedious, right? These are the different things. Now let's just look at it. It's a lot simpler to look at it. So basically, these things are labeled. This is the origin. This is the abscissa scale. They're telling us it's sessions. That's the identification of the variable of time. I'm going to go this way. We have percentage of correct multiplication problems, which is the identification of the ordinate value. That's our dependent variable. We're identifying the condition, so baseline versus intervention. In this particular example, this is that within phase identification. So, you know, you had the condition phase change line. This line shows when we changed from baseline to intervention. And then there was something that they did, which was referred to as CRF, some kind of a math thing. It's not what we did last week with Golnoza's study. It's just something else. I don't know what it is. And then they also did something called VR3. And so then we have this dotted line, phase change. And then there are these tick marks. You know, we could read this article, but we're not really going to do that. This is just, you know, showing you a lot of different things on this one particular figure. And this one is for one student named Jen. Okay, so that's it. That's a figure. Okay, now if you want to know all of the rules that are needed, I took the chapter and I condensed it into a handout. And some of the things basically to be careful about is you want to graph your data so that you don't have anything distorted so that it artificially looks better than the data actually is. That's what it comes down to. There are rules. You can look at the handout. I'm happy to talk about it with anyone who wants to. Okay, so now I put together these slides some time ago. In each of the next 3 slides, you will see links which will go to tutorials that are different, which will show how you actually graph data, and different people like different options. So the first one is a presentation that was done a while ago by a student whose name was Laura Marie Pope, and she was at a AAC, or Alternative Augmentative Communication Colloquium. She was a student at Penn State University, and she made a presentation on how do you actually graph single subject research data. It's actually really pretty good. So the thing to do is click on the link. If it doesn't open for you, I am taking the same presentation, the slides, and putting the slides into our Google Drive, so you could copy and click on the link directly through that if you can't do it while you're watching this here. It does work. I think it's pretty straightforward, but we'll go on to some more technical demonstrations of how to graph data. So then the next one, another option, came through a different resource that was from PubMed. PubMed is a search engine. It's associated with the National Institutes of Health in the US. And this will be a different link to click on and to see the graphing example. This is the main link. Third option, which goes into so much detail, but it really walks you through very carefully. This is from the University of Connecticut, and they have Again, just really laid out very carefully how to graph your data. So we can come back to this. In a sense, I don't know that it's that important during our time together, especially because nobody's really having data to work with. If you want, I can get some data. I do have a sample data set if you want to try doing it. But we'll leave it at this for now. You tell me on Friday what you really would like to do. Okay, so that's it on the visual analysis, excuse me, on the graphing of data visually, not on the visual analysis. That's actually another topic for the next week. So taking a break, let's go back to some of the fundamentals on coming up with a really good research question and using logic or logic models or theory to plan your project. And I definitely need to acknowledge a colleague who is a wonderful single case research design researcher who trains other professors in the America and elsewhere about single case design. And I had her as my instructor with a training that was through What Works Clearinghouse a couple of years ago. She's from the University of Oregon. And so acknowledging her, this is my presentation is based on her presentation. So the logic models are going to help plan your research project. So I'm going to go through a few slides. Hopefully it doesn't get too complicated or dense, but let's see if I can convey the information easily to you. All right. So the first point is that we want something called cascading logic. And that's on the top half of this slide. Cascading logic means we're recognizing that multiple things are happening. For example, there's an intervention, which is including teacher training. And then after the intervention, there's a change in teacher behavior, and the change in teacher behavior is going to cause a change in student behavior. So there's several different things going on. That is better than having a simple view, which is on the bottom here, which is that you have an intervention that's teacher training that results in the student changing behavior, because we're leaving out some important things. That's basically the idea of cascading logic. Okay, so let's move on. Now we're going to talk about how you build your own conceptual model using this kind of logic. This slide is going to get full, but I'm going to start on the right and move left. The first thing I need to think about is my dependent variable. What am I going to measure? What is it? How do I measure my dependent variable? What's my outcome? What do I want? What do I want to promote? What do I want to change? What do I want to improve, etc.? Then, moving backwards, I need to think about there may be one or more core variables or core activities or core aspects to my intervention. We've talked about multiple component interventions. There could be a single component or a multiple component intervention, but these are the core elements of the intervention. Okay, but they don't occur in a vacuum. There are actually variables, which in this model are called context variables, that are going to affect the core variables. I'll go into an example shortly, but I'm just laying out how this model works. So we have the intervention elements, then there's some contextual elements that affect that, and then there are actually some setting conditions that are the bigger context about how you define the problem. Okay, so that's almost done, but basically we want a causal inference for, it could be one core element, or I could actually have a box where all three core elements are going on. It depends on your design, but we want to see about a mechanism between the intervention elements and the outcome. Okay, but we have to consider the larger context. This might not make that much sense, but maybe it will if I go into an example. So let's try. Now what we're going to do is we're going to build this thing where, okay, we're going to have I didn't need all that animation. I forgot it was there. But we're going to, in my example now, we're going to have a research question that's focused on the impact of changing the rate of instructional pacing on classroom disruption. So that might be a lot, but basically the idea here is that teachers who are not sufficiently quick when they are teaching students, the students might get bored and be disruptive. So my dependent variable is something related to classroom disruption, and I'm going to focus on the core variable of changing the rate of the pace. And then I could ask, what would be a research question? Could you come up with a research question that basically captures what is going on in this, this potential study here? Well, I'll show you. Okay. Oh gosh, I hope it's not. Oh, it's going to animate, but here we go. There. So the question might be, and this is a formal way of presenting a research question, is there a functional relation between high versus low rates of instructional pacing and level of classroom disruption and non-compliance? So I'm operationalizing pacing as to high and low rates of pacing. Okay, so the research question is testable. We can do that in a study, and we can decide based on an outcome of collecting data with an intervention designed to do this, that we could see if there's a causal connection or not. Okay, so going through this conceptual model is intended to help you come up with a good testable research question. And the example here might seem clear, might not. We'll talk about it together on Friday. But my point is, I want you to be thinking about all of these different aspects to come up with your research question. Okay, now the last thing here is, again, the animation is a little bit odd, but I put in these bubbles to try to get at, good, there's my arrow. So moving from right to left, my outcome is classroom disruption and non-compliance. I could graph that, I could observe that, I could have inter-observer reliability, IOA, I could actually check that, and I could change my instructional pacing, high and low. And then the context, though, for the pacing is that, you know, there's something else that needs to happen. For example, we would want a situation where the teacher had clear classroom expectations, that they were defined for kids and taught, so the classroom expectations are clear, that the curriculum content, whatever I'm teaching the kids, is actually appropriate, and that the students have opportunities to respond. Because if I have these things in place, then the pacing may make a difference. See, we need to know that these things are in place. And there could be other things in place here too, right? But these are examples. And then the fact that you've got things going on in the classroom is actually within this greater context where I have school-wide discipline systems, like school-wide expectations, school-wide consequence, and generally social rewards for appropriate behavior. So if I have this big system in place, and I have at the school level, then I have classroom things in place, but then it still might make a difference about the pacing. I could measure that and see what happens with the outcome measure. Okay, thanks for hanging in there. I'm going to go on to something else. So, not to make this presentation too long, but when we are together, I'm going to refer to the handout, which is Appendix 13.2, which will help us evaluate single case research design. So please take a look at that in the Google Drive. The last thing is here that also on Friday, I will have a list that is popular journals, popular, loosely defined. There's so many out there. I'm going to go to probably journals that are high quality journals, as well as mid-quality journals in special education and psychology, as well as speech language pathology, because I think that will be relevant for some people's interests. So we're going to work together on Friday, mostly on the last two things that I just briefly mentioned here. I hope this has been helpful, and I look forward to hearing your reaction. Please remember to look at the closed captions that are translated for you. Thank you. Hope you all are having a good week.